cars. Hundreds of them. Millions of them. Symbol of prosperity. A few years back, in the 50s, do you remember, suddenly every family seemed to have a car, except, of course, the Joneses. The Joneses already had two. At that time, the rising flood of cars from the factories seemed to symbolize the growth of Britain's economy. The tide of affluence was flowing in the kitchen, too. Mrs. Jones and many of her neighbors already had a fridge and a washing machine. And now the man was bringing Mrs. Jones one of those newfangled spin dryers. But the real point was, whether you bought a washing machine or a car, you were buying sheets of steel. So really, steel sheet production was a truer guide to Britain's growth. And here was the trouble. By the mid-50s, the British steel industry was already working to capacity. To keep pace with the growing demand, some steel had to be imported. Between 1952 and 1955, imports of steel sheet multiplied nearly 6 times. But this was economic madness. For us, an industrial nation, to import a semi-finished product that we could very well make ourselves, if only we had more plant. This was a challenge someone had to meet.
That someone was us, the firm of Richard Thomas and Baldwins. At our works at Evervale, we were already making a not inconsiderable contribution towards the nation's needs. Now it was decided, with the approval of the government, that we should build a new plant incorporating the most advanced methods to produce another 1.5 million tons of steel a year. Then came the question, where was the new works to be sited? The location could greatly affect our cost of production. Our customers are mainly in the Midlands and the London area. We needed to be reasonably near them. Then we have customers overseas too. So we needed to be near a port for the export of our products and also for the import of high-grade ores from abroad. We also needed easy access to our established sources of raw materials in Britain, coking coal and limestone from the hills and valleys of South Wales. Our works at Evervale was having to buy in steel slabs so as to meet its orders for steel sheet. Here was an opportunity for coordination if the new works were sited close to Evervale and its rail link with Newport. Within this area, other needs narrowed the field. The need for vast supplies of water, good rail communications, and a level tract of land. It had to be large enough not only for the works, but also for future expansion. Out of the whole country, the place that best conformed to the economic and geographical requirements of the project was a flat stretch of meadowland in the county of Monmouthshire, east of Newport, in the country parish of Llanwern.
Bringing a dirty great steelworks to a country district like ours wasn't going to be all plain sailing. Did they think they could just charge their way through regardless of the people who belong here? What were they going to do to the countryside? Put a bulldozer through the lock? If they interfered with our ditch system, the whole area would become one big bog. Look at the roads, high and dry above the fields. Why? To keep a way open to the sea wall. Don't forget this is land reclaimed from the sea.
Yes, we did have a nasty flood once. The sea broke through and drowned 2,000 people, they say. You can see the high water marks on the churches to this day. Now, we don't want the same thing to happen again, do we? Oh, this has always been a peaceful place. Fresh air, fresh water. What they want to go spoil it for? What is this life, live full of care? We have no time to stand and stare. W.H. Davis wrote that. He came from around here. Oh, the good old ways, you know, the country ways like. They die hard with us. My grandparents are lying here, and their parents too. Nowadays there's more people in the churchyard and perhaps fewer in the church. But there's no real change. We're still country people.
In Newport at County Hall, the project had been submitted by the company for planning consent. The planning subcommittee and its officers discussed the company's plans and grappled with all the problems the new works would present to the area. They were anxious how such a large plant could be assimilated into the countryside. They had to foresee its effects on the rural community. Being the county planning officer, I had to examine all the details submitted by the company of layout, design, elevations and landscaping. The project would have considerable effect on property rights and boundaries in the area. New common land would have to be provided by the company. Water supply would be another big problem. We'd have to guard against pollution of rivers and streams. And another headache would be communications. At the eastern end of the works, a new access road would certainly be needed and a greatly improved crossing of the railway. Thousands of men were coming to work on this spot, many of them family men. Were the nearby villages of Llanwern, Bishton and Langston to be turned into a steel town? Certainly not. The county council decided that new housing estates should be added to establish communities within travelling distance of the new works. At Risca, Killeen, Llanmartin, Caldicot, Chepstow, and also at Cambran Town. This meant new bus services to and from the works, though many workers would have their own cars. In County Hall, things sometimes seemed to be getting out of hand. Housing estates meant children, and they meant schools. The county council had to do more building than the company.
In August 1959, the first of our men arrived on the site. One of the first jobs was to level up the ground. The original idea was to suck sand up from the estuary for this, but that could only be done at certain times of the year, and we couldn't keep to our schedule that way. So we brought shale from colliery tips all over South Wales. To do this, we hired lorries from private contractors all over the country.
The shale lorries, that's something we'll never forget. Rumble, rumble, rumble all day and all night.
We brought 9 million tons of shale from tips 50 miles around and improved a number of Welsh landscapes in the process. We laid down roads connecting all parts of the site with one another. The main watercourse, called the Monk's Ditch, crossed the site and had to be rerouted to fit in with the plan. 93,000 piles we drove to the hard rock 35 feet below. At one time, nearly every piling rig in the country was at work here. 3.5 miles long the site was. We got the foundations prepared and the buildings started to go up. North of the main site on Waltwood Hill, we dug out a new reservoir to store the water brought from the River Usk. The works would be drawing 14 million gallons of water from here every day. Water's vital when you're making steel.
And so are skilled men. The number of skilled men we should need when the works was finished was going to be hard to find. We started training apprentices in temporary workshops and classrooms. It was an exciting time for them to see the works they were going to man growing up around them. 1961, we got the first equipment into commission. That was the tippler for the iron ore. Then, in the following year, the pieces of the jigsaw really began to fall into place. The result might have been an ugly conglomeration, but our architects had designed the entire works as a unified whole. We'd come a long way from the image of dark satanic mills that Blake stamped on industrial England.
Who's talking about England? Monmouth says in Wales, man.
The 26th of October 1962 was fixed for the official opening of the Spencer Works. Her Majesty the Queen had consented to perform the opening ceremony. For the occasion, we had part of the works transformed into a banqueting hall. Several hundred guests had luncheon and heard the Queen speak. After luncheon, the Queen and the Duke of Edinburgh went to the slabbing mill. For the opening ceremony, a steel ingot was brought from the soaking pit to the rolling table. The Queen pressed a button, and Spencer Works was in production.
By the time the works was in production, the population of my parish went up from 334 to several thousand. On most days of the week, and sometimes at night too, I go into the works to meet and to talk with the men. Most of them live outside my area, but some of them do live in the old parish, and it's very pleasant not only to see them in church, but also taking part in the affairs of the parish generally.
Oh, yes, the steel chops have settled in here well enough. Mind you, when they join us in praising the Lord, we sometimes wonder whether we're all thinking of the same wondrous works. Down at the pub, things have changed since the works came. They built on a smart new bar and a terrace. Very up-to-date it is. Aye, things are changing everywhere. With all the extra cars and lorries on the road, new filling stations and garages have sprung up. There's a difference in the traffic nowadays. In Newport, the corporation's built a new road bridge over the river. Hold-ups on the old one was something dreadful before that. Sometimes of the day it took you an hour to drive into town. Everybody felt some difference. It was good for some, of course, and bad for others. If you were buying a house, well, you've left it too late. The prices in Newport went up £500 all round. Shops and offices too. It was the demand. Wages went up too all round here. There's no doubt. There were more men earning more money and more women spending it.
Men came to work at Llanwern from all over Britain. Many from other steelworks, quite a lot from other industries. Some settled down better than others. A lot depended on how their wives settled into the new houses built for them. And a lot of that depended on how happy their children were in their new schools. The opening of the works meant a fresh start in life for a lot of people.
Well, you don't want a lecture, do you, on how to make steel? Every schoolboy seems to know that nowadays. At Spencer Works, we follow the same sequence of operations as other people. Only we think our methods are a bit better. For instance, we don't usually put raw iron ore into the blast furnaces. We sinter the ore, fuse it with coke, to make it easier to extract the iron. Our sinter plant is the largest in Britain, and the whole plant is controlled automatically. The mixture, the fuel, the water, and the flow of materials. Then the blast furnaces. They're the first in the country to be charged entirely by automatic controls. A fall in the level of the material in the furnace sets off the charging process. Hopper to conveyor, conveyor to skips, skips to furnace. It's all automatic. At the steelmaking plant, we use only the most modern process, LD converters, 3 of them. Each one produces 100 tons of molten steel every 45 minutes.
And a lot of fumes and dust into the bargain. The first year you were here, there was that red iron oxide dust over everything. I've heard of oxide daisies. I was getting oxide dahlias.
Well, I'll admit we've had our teething troubles. And a breakdown means either letting the dust get out until the fault's repaired or closing down the plant. And nobody wants that. I can't promise we'll never have any more breakdowns, but we'll do our best. And you know, we are the first steelworks to be built since the passing of the Clean Air Act. So we're pretty conscious of our responsibilities in that line. Our coke oven chimney has been built 250 feet high so that the smoke will be dispersed well above ground level. Our surplus coke oven gas is ignited and burnt. Sinter plant dust is prevented by electrostatic precipitators from escaping to the air. Even the slag we make is not piled in unsightly heaps. It is processed on the plant and made into material for surfacing roads.
Ah, yes, but what about those piles of coal and iron ore and what all lying around? In Llanwern, every time there's a sea breeze, we know what'll happen. We'll get the dust over everything.
Well admitted, the stockpiles are a problem after a spell of dry weather, and frankly, there's really very little we can do about it, though we're planning to try the effect of a screen of poplar trees. The people that get it worst, of course, are those in the road nearest the works. Some householders there wanted to move when we came, so we offered to buy their properties at a fair valuation, and then we let them to our own officials. If they find that their families are noticing any dust or fumes about, you can be sure they're the first to get on my tail.
Under the Clean Air Act, the local authorities have a duty to guard against air pollution. As soon as the building of the works began, we set up a number of atmospheric testing stations in the neighbourhood, so that the difference the works would make could be measured. Before work began on the site, the dust content of the air was, of course, very small, except in one place it's only 1/5 higher now.
At Spencer Works, making ingot steel is only the beginning. Steel sheet is what we make, and the hot mill where it's rolled from slab is the centerpiece of the works. A damn big centerpiece, too, nearly half a mile long from the soaking pits at one end to the coiler at the other. And the sequence of processes here is almost fully automated. A number of sensing devices throughout the mill feed information to the mill's own online computer, which controls every stage of the steel's progress from slab to coil. A computer reacts quicker and more accurately than a man, however skilled he is. That is why our computer-controlled hot mill is turning out steel coils of consistently higher quality than we've ever been able to achieve before. The hot mill computer gets its operating instructions from the computer center. The computers here are mainly concerned with processing information. Customers' orders, for instance, come in here, are put out as punch tape, and fed into the scheduling computer. It is this computer that gives the hot mill computer its production program. Another computer here correlates and issues control information to various points in the plant. And another is used for research and to analyze operations for quality control. We can't say yet that the whole works is automated, but we've gone a long way in that direction, and we're still moving.
From the golf course, you look down over the works to the sea in the distance. We've seen a little what the coming of the works has meant to our neighbours here. But what about the wider effects? What about that challenge we had to meet? In the coal mill at this moment, you can see the strip being put through its final processes. It's pickled to clean off the scale, coaled reduced to the specified gauge, annealed and tempered to the finish required, coiled or cut up into sheets. A consistent high-quality product, as good as the care of skilled men in a highly automated plant can make it. The finished products of the coal mill, plus the heavy gauge sheets and plates that come from the hot finishing plant, amount to nearly 750,000 tons of steel sheet a year. for British industry and for export. And the point is, this is 750,000 tons that Britain couldn't produce before the Spencer Works was built. Instead of our economy being held up in a steel bottleneck or dependent on imports from abroad, now we can feel confident of meeting our own requirements and of exporting steel sheet too. And with all the land alongside earmarked for extending the works, we can keep pace with any expansion of demand for many years to come. Britain's economy is always being threatened, it seems, in one way or another. Here, at least, one threat has been boldly and effectively dealt with. Not that we can sit back. In this business of making steel, you've always got to be looking and moving ahead. But already it's clear we've a job here we can all take some pride in. We've built a great, intricate machine, and with effort and skill, we've made it tick.
I've been here right from the beginning. Funny how it gets you. First you're feeling your way all the time. Then after a bit it becomes something you take in your stride. All in a day's work. A year or two ago it was a new job and a new house, new prospects in a strange place. Now, well, we've settled down. Just like the works. Our home's here and our future's here at Llanwern. We've almost forgotten what life was like before the works was built.
Indeed, that's true. Even to us who've always lived here. Or it soon will be.
March 1961 finds the Spencer Works well into its second year. So let's take advantage of exceptional spring weather and make a progress report. With a site that stretches along 3 miles, there's only one way to view it, and that's from a helicopter. Up and away on an aerial grand tour that will take us from one end of the works to the other. We're traveling from west to east, first looking at the office blocks on the left, and then at the rail sidings where trains will deliver stocks of ore and coal. The production process, from ore to steel sheet, will flow in the direction in which we're traveling. Now the tracks of the boom cranes are becoming apparent. Further on, the coal handling plant progresses. That long covered building conceals the 4 batteries of coke ovens, with the square coal storage bunker in the middle left. Here's the sinter plant, and soon we're flying over the old Monk's Ditch, now diverted into a straight, clean concrete bed. Passing by the twin cooling towers, which rise head and shoulders above everything else, we come to the heart of any steel works, the blast furnaces. The first one is well advanced. The second is still an infant. From the blast furnaces, iron will flow into the adjacent steel works, now beginning to take shape. The white patch in the middle distance is the first cladding on the enormous hot mill building. Over the whole site, infilling and piling are nearly finished. Foundations are firm. From now on, it's a matter of setting the body on its legs. And astonishingly, we're still following the length of the hot mill. In time to come, the steel strip from the hot mill will go to the pickling bay, and then for the rolling and finishing to the cold mill, which adds its length to the seemingly endless production line. Everywhere over the site, there are huge deposits of raw materials: sand, cement, and steel. At last we come to the eastern extremity of construction, bounded by the perimeter roads. Then it's the green countryside of Monmouthshire, and over the London Newport railway link. Well, that's the Spencer Works from a distance. Let's have a closer look at some of the details. All day long, the feeder roads and railways are choked with heavy traffic. The construction of a plant covering many hundreds of acres and employing thousands consumes an enormous amount of material every hour of every day. Everywhere, men at work. Despite the latest machinery, the manual labourer still has a part to play. Railways are an essential means for bringing in heavy and bulky material, so rails are laid, 25 out of an ultimate 40 miles of them. Now we're flying over the beginnings of a coke stockpile. Coke is being collected and stored already, awaiting the future demand. Rather like priming a pump. And here's another kind of pump priming with men. When the steelworks is operating, there'll be a pressing need for highly skilled manpower. It takes a long time to build up a team of specialists, and so among the first things to be built on the site were lecture rooms and workshops. At this very moment, they're filled with young apprentices, training for the day when the works will be completed. When they move in, each man will have to know his job. Already, nearly all the offices are fully staffed. Providing meals could be a problem, but for pleasantly designed dining rooms and canteens like this, which are already in service. Anyone would be glad to meet and eat in such surroundings. On these grounds alone, the Spencer Works would be a popular place in which to work. Production, the works will consume millions of gallons of water every day, and the reservoir in the Dimple on Waltwood Hill is already taking on firm and definite proportions. This artificial lake will be large enough for yacht racing. Tons of concrete are being mixed and poured to form the walls of this reservoir. 2 walls of the reservoir are nearing completion, while work is proceeding on the 3rd. Originally, the whole of the Spencer Works site was a marsh, and the whole plant had to be built upon sunken foundations which reached down to the bedrock below. To take the weight of the boom cranes in the ore stockyards, special hollow concrete piles are built on the surface and weighted down. The top of the cavity is sealed off and compressed air pumped in. This prevents water entering while the men inside the caisson control the excavation of the soft earth. Each pile is an island in a pool of bubbling mud. This is the effect of the internal air pressure. A man needs a tough constitution on this job.
Now we're looking again at the coke ovens. They're under a temporary cover whilst being lined with fire bricks, which must be kept bone dry. The main storage bunker, still to be completed, will hold the coal for charging the coke ovens. Concrete, concrete and more concrete. How many cubic yards have gone into this structure? An army of quantity surveyors spend all their time wrestling with the staggering figures. Ore and coke will be conveyed to the sinter plant along an overhead conveyor. And that's only part of it. The other half will carry the sintered material to the blast furnaces. Rows of rollers seeming to stretch to the horizon are already installed on some of the conveyors to carry the belting. Only from a helicopter could we see a cooling tower from this angle. The men working on the rim provide a contrast for size. And now we have a better view of number 1 blast furnace, dwarfing the derrick that erected it. It stands by its blast stoves and other attendant structures. After the steel overcoat, the brick underwear. Tons and tons of specialized bricks for the stoves. Up on the monster itself, dazzling pinpoints of light locate the arc welders at work. The most massive structure on the site, the steelworks, the housing for the first of the LD converters. The hot mill, represented by acres of roofing. With a little imagination, one can even envisage a game of football on it. There's the wall cladding we saw earlier from the air. Cold mill. The tiny workmen on the roof look as though they're crossing a vast desert. Underneath, and supporting the great flat roof, is a forest of girders and steel structure. A quarter of an hour later, we descend to terra firma, remembering that this marshland was once anything but firma. After this second aerial survey of the work's progress, the vastness of the project becomes more apparent than ever. For this site, once a marshy piece of farmland, will soon enclose one of the biggest steelworks in Great Britain.
A pretty familiar sight these days. A heavy load taking every corner an inch at a time. Quite a worry for the driver, but this one's done it all before. This casting is on its way from Sheffield to Newport, Monmouthshire. For at the new Spencer Works of Richard Thomas and Baldwin's, things are pretty advanced. It's late summer, 1961. From the air, it's now apparent that the summer has seen many changes at Spencer Works. Even from afar, there's a look of near finality about many of the structures. This is deceptive. A closer look would reveal much detailed work yet to be done. But from a height, the shape emerges. The plan is defined, and blueprints have become a three-dimensional reality. The site between the hills and the sea is so vast that an aerial view provides the only way to survey the project in its entirety. Signs of the completeness of the buildings are the splashes of bright color supplied by the final coat of paint, already covering some sections. Let's just sit back and fly right to the eastern end. Back on the road, the big casting is now free of corners for a while. Time is important. Each load to Newport travels within a controlled scheme. The right component at the right time, at the right place. A jigsaw puzzle of transportation and administration. The Gloucester City, just in at Newport docks from the USA. And from the ship, another massive weight bound for RTB from Pittsburgh. This is the only floating crane in the South Wales area capable of lifting 100 tons weight. But to get the casting to the site, a short trip by road. It's the devil's own job to lift from deck to low loader. Painful slowness and patient skill alone make sure that such a load arrives safely. Up at the works reservoir, the concrete is nearly completed. It won't be long now before the first gush of water is pumped in. But what about the outlets? Miles of pipes lead from the reservoir down to the main site. These pass over the main Western Region line from London to South Wales. It's now just a matter of welding and covering before the day when they'll be ready to take gallons of water a second down to the thirsty production area. Water isn't the only thing that's going to travel by pipe. There are miles and miles of pipes to carry all kinds of gases and liquids running throughout the site. The circulation system of a giant covering 4 square miles. Well, the Sheffield load is making good time now, making up for all those slow corners.
It won't be long before the iron ore starts to arrive at this tippler. The rails are already being laid and connected to the main line. The man at this control console will be in charge of the whole operation, including something called beetle behind rear wheels. Each truck will arrive and be turned over to empty the ore onto conveyor belts. The belts are already going into position, a matter of great precision. An enormous area is cleared for ore storage. Already at Newport Castle is the convoy from Sheffield. Newport is a changing place. The new works will make a big difference to the whole area in the years to come. Meanwhile, traffic in the streets has to pause from time to time to allow access to slow, heavy, low loaders. Now the people of Newport can begin to see the immensity of their new neighbor, for its solidity and weight are becoming more and more apparent to passers-by. This building will house the steel-making plant. Spencer Works will be the first works ever to rely entirely on the LD process of steel-making, in which a jet of pure oxygen is blown onto the surface of the hot metal in a converter. There'll be 20,000 tons of plant, equipment and material supported on those girders when the plant is working. There's a feeling of near completion about these days. It's certain that when the steel begins to flow, Newport will have an industrial center of national importance on doorstep. There's capacity here for adding another 35% to the United Kingdom's 1960 output of sheet steel, and space to add very much more. But for the moment, walls are going up around the steel skeletons. Section by section, the cladding encloses vast interior areas, creating shelter within and a bright completeness without. All through the year, large structures have been hidden by an overcoat of scaffolding, but now this begins to peel away to reveal new shapes and textures in the completed buildings. Paint shines everywhere, and red undercoat gives a touch of gaiety to the look of the place. Whole structures begin to shine with a new brightness, soon to be shaded by wall and roof cladding. The road convoy has arrived, on time and all in one piece. Into the cavernous interiors, slowly and carefully. It's now up to someone to sign on the dotted line, received in good condition. From now on, the main developments at Spencer Works will take place inside, away from the sun and the rain. Installation will replace construction. Micrometer and caliper will replace bulldozer and excavator. Very soon, Spencer Works will be a permanent part of the daily life of Newport and miles around. Spring 1962. The outline of the new Spencer Steelworks near Newport, Monmouthshire, is almost complete. From end to end of the 3.5-mile site, construction now moves into its final stages. In many instances, it's necessary that some of the heavier items of plant and equipment are installed while the buildings to house them are still being constructed. One such building is the steel plant. Here, work on the structure and the delivery and erection of the LD vessels and their equipment proceeds to a coordinated schedule. The coke ovens byproducts plant is quickly taking shape, and most of the major items of equipment have arrived. It was only a few months earlier that the top of Waltwood Hill had looked like this, as work was in progress on building the reservoir for the works. Now the job is almost finished. And in fact, one section has already been completed and filled, ready for use. At the coke ovens site, the construction program has reached the point where batteries 3 and 4 are well underway, and numbers 1 and 2 at the far end are almost finished. Another couple of months will see this first battery going into commission. And in readiness for this, the rams for discharging the ovens have already been erected, their machinery installed and put under test. Gas from the coke ovens is supplied in great quantities to the soaking pits and other parts of the works, and the huge piping for this goes into position. At the sinter plant, where iron ore will be fused with coke and turned into a material more suitable for modern blast furnaces, structural work and installation have both reached an advanced stage. The first of the 3 LD vessels is now in place in the steel plant, but before it can start converting iron into steel, there's a lot of work for fitters, grinders and welders yet to be done, both on the vessel itself and on the equipment that goes with it. Like everything else in this up-to-date works, each of the 3 vessels has the fullest instrumentation and control system, centered in a nearby cubicle. Control circuits are also among the many items to be installed and checked on the 6-stand mill. In time to come, this group of machines will be controlled by a computer for the first time ever outside the USA. There's a long job of fitting and testing here before the plant can be commissioned and before the computer can be programmed to take over control. Now this great new British steelworks takes a major step forward towards full production with the commissioning of the first batteries of coke ovens. At a special ceremony, Mrs. Campbell Adamson, wife of the works general manager, lit the first of the 70 ovens completed. She's followed by Mrs. Raymond Raby, wife of the coke ovens manager. The importance of the occasion attracted a crowd of press and television cameramen to record for publication this red-letter day in the history of Spencer Works. And so, little more than 2 years after construction began, commissioning has started. Up at the reservoir, everything is now ready for the start of production. 100 million gallons of water waiting to meet an initial daily demand of well over 14 millions. And back at the works, the ore tippler comes into operation, handling trainloads of ore. The whole procedure is automatic, beginning by hauling each wagon to the top of the slope at mechanically preset intervals. The next operation clamps the wheels in a transfer mechanism, and the wagon is then moved on to the actual tippler. Every stage of the job is electronically controlled, and the very minimum of supervision is needed. The ore that is tipped from the wagons passes through a crusher and then is taken by conveyor belts to the ore stockyards. One is reserved for foreign ores and another for home ores. And stocks are built up here in readiness for production. At the coke ovens, the fire brick linings are slowly warmed up over several weeks before they're charged with coal, and an operational routine begins with regular inspection and supervision. Beyond the line of the coke ovens, a quenching tower stands, ready to handle the output of coke needed to feed the work's 2 blast furnaces. Waiting too are the great coke cars serving this plant. And while the coke plant has reached the point where production is almost beginning, the finishing touches are being given to the sinter plant. Here, twin coolers are ready for a final coat of paint, while the last stages of erection still go on nearby. All that now remains is for the insulation and painting to be completed on these hoppers, and the plant will be finished, ready to enter into full production. In another part of the sinter plant, the precipitators are in use, and close by stand the hoppers containing the various grades of ore needed to make the sinter. As the target date for full production approaches, the coke ovens start to play their part. Coking has started. A coke push takes place here at short intervals throughout the 24 hours of every day. From the battery of ovens, it's only a short run to the quenching tower, which is one of the places where water is needed in abundance. In the big reservoir overlooking the works, there's now plenty of water, not only for coke quenching, but for cooling the blast furnaces and the mill rolls, and for many other purposes. The gas main from the coke ovens gets its final coat of paint. Of the 2 blast furnaces, number 1 is almost completed and is the first ready for starting up. Preparations for this include warming up the 3 blast stoves and also checking over the electronic control panels for the automatic charging gear. June the 1st, 1962. And number 1 blast furnace is about to go into service. Mr. H.F. Spencer, the managing director of Richard Thomas and Baldwin's Limited, performed the lighting up ceremony. In a short speech, he told the gathering of RTB executives and contractors' representatives that Spencer Works is as up-to-date a plant as any of its kind in the whole world, and that while all the plant is modern, the majority of it is the most modern in the world. He went on to say that he hoped that it would not only bring more prosperity and importance to Monmouthshire, but that it would also enhance the economy and security of the country. He concluded his remarks by wishing all who tend the blast furnace good luck and prolific tappings. Lighting the blast furnace was another important step forward to the day when Spencer Works would start integrated steel production. But meanwhile, other parts of the plant are also being brought to a finished state. Among these is the motor room for the universal slabbing mill, where the motors are almost ready to make test runs. It's from here that the big rolls of the slabbing mill are driven by 6 motors, which together give a total of more than 16,000 horsepower. Two pairs of motors drive the upper and lower horizontal rolls, and 1 pair the vertical rolls that are a special feature of the mill. And of course, the mill machinery is served by the most modern instrumentation. And now, back at number 1 blast furnace, they're just about to start casting. That is, tapping off the iron. Casting takes place once every 4 hours, and each of the 2 blast furnaces at Spencer Works will eventually produce 2,000 tons of iron every day. The stream of molten iron is run off into ladles positioned below the openings in the cast house floor. To see that the iron is up to specification, samples are taken from each cast as the stream flows on to feed the steel-making plant. July 1962, and an ingot of steel starts its journey through the slabbing mill. The slabbing mill is at the beginning of the hot strip mill, which altogether is 1,800 feet long, one of the longest in the world. The universal slabbing mill is used for the first stage in the process of turning ingots into steel strip. It has a capacity for handling ingots up to 30 tons in weight. For the first few passes, the ingot is rolled on edge between the horizontal rolls, which are adjusted at each pass. The whole operation is controlled from what is called the pulpit, which stands across the line of the mill. In here is one man who manipulates steel ingots through the powerful mill as easily as if he were driving a car. After the first few passes, the ingot is turned on its side, and from now on the vertical rolls control the width, while the horizontal rolls progressively reduce the ingot in thickness, increasing its length till eventually it becomes a slab up to 30 feet long. Slab, produced in Britain's most up-to-date mill, is the forerunner of the countless number that will pass through it in the months and years to come. Spencer Works, a giant in modern steelmaking, has...
1962, a train drew eastwards bearing the Queen and her consort towards the proud towers of a giant industrial citadel. A citadel, moreover, that had newly risen like a dream from the marshes of a wasteland. Once a dream, perhaps, but now triumphant reality. This is the most modern integrated steelworks in Europe, the Spencer Works of Richard, Thomas and Baldwin's. At 12 o'clock, the royal standard was raised over the huge plant. The Queen had arrived. From the special platform, Her Majesty appeared accompanied by Lord Raglan, the Lord Lieutenant of Monmouthshire, and followed by Prince Philip, the Duke of Edinburgh. The school children of Llanwern had come in a body to greet the Queen on her visit to the plant where many of their fathers worked. Her Majesty and Prince Philip were met by the chairman of Richard, Thomas and Baldwin's, Mr. Geoffrey Ely, who presented his wife. He then introduced Mr. and Mrs. Henry F. Spencer. Mr. Spencer is RTB's managing director, and the new steelworks have been named after him. From the arrival point, the royal guests were taken by car for a drive along the whole length of the site. They passed the tipplers, completely automatic in their operation, where the incoming ore is weighed and crushed and then transferred to traveling belts that carry it to the stacker. Past the battery of coke ovens, where the 22,000 tons of coal that come in each week are processed into coke, and passed to the quenching tower before going on as fuel for the iron-making process. Past the plant where the coke and ore is sintered for charging the two giant blast furnaces. Each of these is capable of producing 2,000 tons of iron a day. Finally, at the extreme end of the plant, outside the cold mill, a reception had been arranged. Mr. Campbell Adamson, the general manager of the new works, was presented to the Queen and Prince Philip. After him, Mrs. Adamson. And
then a number of the directors and leading officials of the company and their wives. In a marquee, inside the cold mill, luncheon followed the reception. In a speech of welcome, the chairman expressed his pleasure at the royal visit. He went on to say of the works,
"For it represents a landmark in the history of this company and in the history of the British iron and steel industry. Its scale is considerable. It covers some 3.5 miles and is over half a mile wide. And it is the most up-to-date, fully integrated strip mill in this country or in Europe and possibly in the world. It has sprung from a greenfield site in about 3 years, and it represents an achievement of which I think we are justified in feeling a certain pride. We've had to remove over 40 miles of hedgerow and to raise the level of the ground by 6 feet. We've used 10 million bricks, have provided reservoir capacity for 100 million gallons of water, and have installed 39 miles of railway tracks and 27 miles of roads. Yet, in all this upheaval and hubbub, wildfowl and swans have declined to desert the area, and we are leaving a few ponds on the site for their especial enjoyment and our own pleasure. It would clearly be impossible to attempt to name personally all those to whom our thanks are due. One man, however, must be mentioned. The man after whom these works have been so properly named, our managing director, Mr. Harry Spencer. In a varied and longish experience, I cannot recall working with anyone who put such single-minded ability, such imagination and energy, and such courageous determination into a great project. This was his vision.
In her reply, the Queen said,
"Modern steelworks are built on such a huge scale that I need hardly say that we are greatly impressed by what we have seen so far. I have no doubt that your many distinguished guests here today are equally impressed. The story of how the Spencer Works were built, of the devoted work of Mr. Spencer and his team, of the large numbers of men in many trades and professions who have been engaged on its construction, and the active cooperation of the local authorities makes one feel a glow of pride for this splendid achievement. I am certain the quality of your output here and the high standard of your productivity will be a great contribution to our industrial effort."
After luncheon, the Queen and Prince Philip visited one of the most remarkable sections of the new plant. Spencer Works is the first integrated steelworks in Europe to be designed for control by automation. Ultimately, all the processes from soaking pit to coiler will be fully automated, though men will still be in charge of the machines. After seeing the automatic controls, the Queen was shown how iron and steel are made at Llanwern. When the blast furnaces, which are charged automatically, are tapped, the molten iron is drawn off. From giant ladles, it is fed into one of the vessels, where it will be refined into steel. The Spencer Works is the first in Europe to make steel entirely by the modern LD method. Each of these huge vessels is capable of producing 100 tons of steel at each cycle of operation. A lance is lowered into the vessel, and at the touch of a button, it blows in a jet of pure oxygen, setting up a series of chemical reactions that release the impurities from the metal. At the teaming bay, 45 minutes later, the refined molten steel is poured into molds to solidify. When the mold is stripped off, the ingot is revealed. A glowing mass of refined steel, the finished product of the steel-making plant, the raw material for steel rolling. The ingot is lowered into the soaking pit for reheating to be ready for this next stage of production. The Queen and Prince Philip then went to the slabbing mill to watch the rolling out of an ingot. They saw one brought from the soaking pit and transported to the rolling table. At this point, the Queen gave the royal command by pressing a button, a signal that started the ingot off on its passage through the mills and marked the official opening of the whole plant. The ingot here went back and forth through the first of the many rolls that were to press it out into steel sheet. Modern technology enables the rolling operations to be controlled by men seated in comfortable chairs. From this pulpit, the roller man turns the ingot over into its final rolling position. The royal party moved on as the rolled ingot took on the shape of a slab. Then the visitors followed the slab on its long journey down the mill. From the run-out table, it passed to the scarf and went on to the shears, which trimmed its rough end. When this slab was stacked for reheating, another reheat furnace for the final run. Roughing stands, growing longer and advancing faster at each stand. At the fixed stand mill, the Queen visited the control pulpit and saw for herself the operation of this complex of machines. At the end of the hot mill, the sheet was quenched and coiled, and finally ejected, ready for dispatch to one of RTB's many customers throughout the world. Having seen many of the processes through which ore goes on its way to becoming steel sheet, Her Majesty and Prince Philip returned down the newly named Queen's Way to take their departure. At the special platform, the royal couple made their farewells and boarded the royal train for their journey homeward. For Spencer Works and for the people of Llanwern, this had been a notable occasion. A royal visit is always something to look back on, and the official opening of a great new works is for all concerned a stimulus of hopes and plans for the future. Altogether, for Spencer Works, October the 26th, 1962, was a great day.
The monks who dug this ditch over 800 years ago to drain the neighboring marshland would be astonished to see what is being built over it today. The Spencer Steel Works of Richard Thomas and Baldwin Limited will be one of the largest in Wales, and 1 year's work of basic structure has already been completed. 83,000 piles will eventually support the heavy plant above the marsh. There, for instance, is the base of a blast furnace with its attendant stoves. Today, the builders are not only draining the marsh, but filling it in as well. It is estimated that some 7.5 million tons of fill is being moved in, dumped, and leveled. To do this, a huge fleet of lorries doing shuttle service are making around 5,000 trips every day. The aim is to provide a firm foundation for the roads and light buildings which will surround the main steelworks. From this angle, the depth of the fill above the marsh is easily seen. Heavy concrete channels will form part of a modern drainage system. But the workmen today still have something in common with the monks of old, with their picks and shovels. The stockpile of sand and ballast on the right feeds one of the batching tires where the concrete is being mixed. From here, it is taken by truck to the construction site, along a roadway still being graded. This hard rock core has had to be quarried and transported from a location many miles away. Accurate surveying is essential on a site that stretches over 3.5 miles, and obviously a bird's eye view is the best way of encompassing the whole project. The first buildings are the temporary office blocks. Temporary, although they may be used for 10 years or more. Most of this wide open space is reserved for the coal and ore stockyards. One of the advantages of the Spencer Works site is the proximity of the London to Cardiff railway line, which runs parallel to the works. The electricity grid also passes close by. The silver and black buildings in the center are coke ovens, and those in front are temporary fire brick stores. The site continues over the sinter plant space, coming to Monk's Ditch, which has had to be rerouted to fit with site planning. In the middle distance, a towering crane works the #1 blast furnace foundation, and behind it is the jungle of the steelworks construction.
We are now moving over what will be the steel-making plant, beyond which piling for the hot mill is already down. Nearby, piling for the cold strip mill is equally advanced. The stretch of water in the background is, of course, the Severn estuary. The site runs out over more storage space and ends at the service road, which runs round 3 sides of the area. Meanwhile, some 4 miles away, 100 million gallons capacity of reservoirs being excavated at Waltwood Hill. This man-made lake will feed the unslakable thirst of the steelworks, which will consume millions of gallons every day. For instance, each time a batch of coke is quenched, 25 tons of water go up in steam. Again, an army of earth movers is required to tackle this part of the project. From above, the extent of the dimple can clearly be seen. Here are the 4 batches of coke ovens. The bricking for the first is in progress. The steel structure for the second is being erected, and these are the foundations for the third and fourth. A closer look at the fourth reveals the strength of the heavy supporting pillars which go straight through the marsh to the rock bed, sometimes more than 35 feet below. The foundations have a curiously classical appearance at this stage. Under a temporary roof, work proceeds amongst the fire bricks. Coke oven linings must be kept bone dry while being installed. The steel structure for the next battery is almost completed. On the left is the main storage bunker. The number 1 blast furnace will be supported by 6 steel legs. The blast stoves are progressing close by. A highly skilled team operate the pile drivers, which are sinking a forest of longer piles where the marsh is very deep. A hollow sheet metal tube is fitted over a rigid core. Then a steam hammer drives both the tube and the core into the ground. The core is then removed, leaving the tube embedded. The tube left above the ground is cut off at a standard height. The concrete filling, when set, will form the load-carrying pile. Finally, the concrete pillars are topped off with reinforcing rods which will connect with the concrete footings to be constructed above. An aerial view gives an idea of the size and number of the huge pillars needed to support the hot strip mill. Underneath the mill floor, there will be convenient space for power rooms and stores. These pillars must take the tremendous weight of the works floor and its machinery. We leave the site with a final view of the basic structure of the steel plant. Already a giant at the end of its first year.